as we had learned in our previous lesson. So today's lesson is a continuation of stratigraphy, and in our previous lesson we said that stratigraphy is the study of rock succession, and today we are going to look at the principles of stratigraphy. So the principles of stratigraphy are used to develop a relative chronology of layers of strata on the earth. So what we're trying to say is that basically in stratigraphy we are trying to look at the layering of rocks, and in today's lesson we are going to look at the 6 principles of stratigraphy. So, and under the principles of stratigraphy, we are going to look at the first principle of stratigraphy, which is the principle of uniformitization. So under the principle of uniformitarianism, it states that the geological processes which are taking place in the present operated similarly in the past. So what this principle means is that basically the kind of layering we are seeing today is not something new that is happening in rocks, but it is something that has existed for a long period of time. And on the picture that we have on the right side, in this picture we can see the sequential layering of rocks, which indicates at the top where we have the trees is what is going on currently, and beneath deep down is what was going on initially. So what we are trying to see is that what is going on today is what was essentially going back previously. The next principle of stratigraphy is what we call the principle of superposition. The principle of superposition states that the rock materials generally get deposited on top of earlier deposits. So basically, when we have the layering that we are looking at on our right side, it means that the rocks on top are younger rocks, whereas those that exist beneath are older rocks. So next, after looking at the principle of superposition, we are going to look at the principle of cross-cutting relationship. So basically, what the principle of cross-cutting relationship means is that it states that in any form of intrusive formation, such as a dike or a seal, the rocks must be younger than the rock that it cuts across. What we are looking on the right side is that on the picture on the right side, we are looking at the gneiss rock, and then we have an intrusion from the felsic dike and the mafic dike. So from the principle of cross-cutting relationship, the felsic dike is younger than the gneiss. So if we are to look at the chronology, or we are to date the rocks, we are going to say that the gneiss rock is older than the felsic dike. Is younger than the felsic dike. So the next principle is what we call the principle of original horizontality. So the principle of original horizontality, so it states that lava flows also tend to solidify as horizontal layers. So lava flows don't only solidify as vertical layers, but also in horizontal layers. So the principle of original horizontality is fundamental because rock layers are often found in non-horizontal positions, indicating that they have been tilted or deformed by tectonic forces. So when we have rocks that have been tilted, it basically shows that these rocks were deposited, but it's only because of tectonic forces that these rocks were tilted or displaced. Next, we have the principle of inclusion. So the principle of inclusion states that fragments of other rocks contained within a body of rocks must be older than the host rocks. So it means that now the host rock solidified in the presence of the fragments of older rocks. So what we can have in conclusion is that the fragments indicated on our right side are older than the host rock. And then after looking at the principle of inclusion, we now look at unconformities. So unconformities occur where erosion has removed rock layers or where layers were deposited during a certain period. So what we are trying to say is that because of soil erosion, we are now going to have various rocks exposed to the surface. And then there are boundaries separating rocks of different ages that typically signal great gaps of time. So when you have now boundaries that are going to be separating rocks, those boundaries are also enable us as geologists to be able to classify rocks based on the times they settle. So as we looked in our previous class, the types of stratigraphy, we have chronostratigraphy, magnetostratigraphy, lithostratigraphy, and basically using unconformities, we are now able to classify all those rocks in their various categories. So class, do we have anyone with a question about what we have learned today? Anybody with a question? Yes, Nelson?
The question is, where can we apply this knowledge?
So thank you, Nelson, for the question. What we mean is that the knowledge of stratigraphy can be applied in dating of the rocks. So basically, as geologists, we are going to use this knowledge of stratigraphy when you're trying to classify rocks according to their maybe ages. So we can say that this rock is dated to 2000 years ago based on the knowledge of stratigraphy and rock succession. We are now able to also classify the rocks on their magnetic properties using magnetostratigraphy. We are also going to look at to classify rocks based on their fossil content using biostratigraphy. So thank you so much. Any other question? So class, as we wind up, I'm just going to quickly go through what we have learned today before I can give you an assignment. So what we have learned today, we had a recap on stratigraphy, and then after having a recap, we look at the principles of stratigraphy. So the first principle we look at is the principle of uniformitization, where we looked at which stated that the principles that which stated that the geological process existing today existed similarly in the past. After that, we looked at the principle of superposition, which stated that rock materials generally deposited on top of earlier deposits. So basically, when looking at rocks, all the rocks at the superposition of rocks that appear on top are older than those rocks that appear beneath. After that, we look at the principle of cross-cutting. So when you have an intrusion in a rock, it means that the intrusion is younger than the host rock. After that, we looked at the principle of horizontality. So in the principle of horizontality, so we looked at the rock layers, which indicated that lava doesn't only solidify vertically but also solidifies horizontally, so that what exists today is a principle of external forces, e.g. tectonic forces, which has caused the rock to alter. After that, we looked at in the principle of inclusivity, where we have the rock segments that exist within a host rocks are now older than what existed initially. So after that, we looked at unconformities. So unconformities are basically boundaries that now separate various layers of rocks. So as we wind up our class, I'd like to give you an assignment. So the assignment that I'm going to give you today is due to be able to describe the various types of unconformities that exist in rocks. The assignment is describe the various types of unconformities that exist in rocks. So the assignment is due to be handed on the LMS, and the date of handing in the LMS will be on 1st of December. So each and every one of you is expected to submit a PDF document, a PDF document of the assignment. So thank you, class, for your time. It was nice having you for this lesson. Hope to meet next week at the same time for the same lesson. So thank you so much.